Hi, chemistry. I'm going to do number 12 in the thermochemistry review. It's asking us about the exothermic formation of nickel oxide. We first have to write the chemical equation for this reaction. This isn't a big deal. So nickel 2 oxide, nickel 2 has an ionic charge of +2. It says so right there. Oxide is -2. So this is just NiO. All right. It's formed from nickel and oxygen. So I'm just going to rush through this. It's going to look like that. Okay, so the next part, where we'll do most of our work here, is discussing 4 grams forming in a calorimeter, this much water, initial temperature. We got to find the final temperature. In order to do that, we need to know the enthalpy change of this reaction. Okay, but it's a formation reaction. Okay, we can look that up. We can look up the enthalpy of formation for nickel 2 oxide. Okay. Here it is, negative 240.6 kilojoules. That's per mole. So I'll write that. That's a molar value. Okay. If we use enthalpies of formation and treat this like a regular equation, we'll do products minus reactants. This guy's negative 240.6. We'll subtract these guys. They're both 0. Okay. So this is our enthalpy change for this reaction. Okay. So that's per mole. We're going to have to do some trig to find out how many moles we're dealing with here. Okay, so we got 4 grams. Now we got to get the molar mass of nickel oxide. Okay, nickel, it's got 58.69, oxygen 16. So I'm just punching this into my fancy sharp calculator. I get 0.054 moles. Okay. Now we're going to be able to find out how much energy is released when 4 grams is formed. We just have to multiply these, the molar value by the number of moles. So I'll call it delta H, number of moles times the molar enthalpy. Okay, so we're dealing with about 12.9 kilojoules. Oops. Great. Okay, so that's what we're going to put into our calorimeter, which is this formula here. Okay, there's one thing to just be worried about when we're dealing with calorimeters. If Q is in kilojoules, that means that the mass has to be in kilograms. So we discussed that. It's easy to forget, though, because we haven't done it in a while. So this 200 milliliters, I'm actually going to say that's 0.2 kilograms. Divide by 1,000. Okay, C is always 4.19 for water. And we'll get delta T this way. Let's see. Okay, I get 15.4 degrees. Okay, it's exothermic. It says so right in the question up here. We know the enthalpy change is negative. So this is a temperature increase. So the final temperature, we just take this initial 22 and add what we got here. So our final temperature is going to be 37.4 degrees Celsius. Great. I hope this helps.